Hello, calculus students. I am sorry that I'm not with you second period. Eighth period, you're watching this in front of me, so if you have questions, let me know. Second period, feel free to ask me questions tomorrow when you see me. We had started this question in your notes during class, and a lot of you got, I think, what was close to the answer. What ends up happening is if you do it slightly different ways, you should still get the same answer, but the way I think a lot of us started it was by taking that x and moving it back up as like a -1, x to the -1. And then from there you manipulated things around. So then you did the quotient rule, low d high minus high d low over low squared, which if you did it from there you would get something that looks like that. But you also may need to simplify a little bit. You probably multiplied through and got fractions. You want to get that common denominator, or you can multiply the whole top and bottom by x squared, hence the x squared here. And if they're both x squared, then I'm trying to write and it's not working. Awesome. There we go. So because of that x squared there, if they're both being squared, you can just multiply them underneath, which is what I did to get the answer over here. The most likely answer that I think you guys should get, and probably the easiest process, is to actually change this into common denominators first and then take the derivative. So if you do that, you end up with this as the same expression, and then you can do low d high minus high d low over low squared. So, excuse me, either way you end up with the -3x squared plus 2x plus 5 all over x squared plus 5x quantity squared. Okay, if you have questions about that, come talk to me at some point. The next one, what I want you to do first is actually the easier way to do this instead of having to do the product rule, because if you did the product rule, then you'd have to do the quotient rule for the second part, which is not fun. So instead, make your life easier and distribute that x squared through first. Get a common denominator, combine like terms, and then it's a lot easier to work with. I want you to take like 2 minutes and just try this. I'll go through the entire work and solution afterwards, but just pause, and then I will show the answer and the work. So if you did it my way, you distributed the x to the fourth, you got a common denominator, meaning you had to multiply this first expression by x plus 1 over x plus 1, which gives you x to the fifth plus x to the fourth over x plus 1 minus 2x to the fourth over x plus 1. Excuse me. So once you combine like terms, you end up with this, right? Except you haven't taken the derivative yet. So you need to do that by doing, again, low d high minus high d low over low squared. So x plus 1 times 5x to the fourth minus 4x cubed minus then the derivative of the denominator is 1, which is kind of cool. This is not working. I'm going to use my finger. Okay. There we go. Okay. So then you basically just distribute everything. So multiply through here. You multiply through by the 1, but then have to distribute the negative. And what you should end up with, got a tickle in my throat, is y prime equals 4x to the fifth plus 2x to the fourth minus 4x cubed over x plus 1 squared. And again, you don't have to expand that out, which is kind of nice. If you ended up with some version of that, that's okay too. Like if you turned the the value of the derivative for the second expression at some point, if you did the product rule, you end up with something similar. But you should always get like that common denominator anyway. It just looks a little bit nicer this way, especially for those of us who like a prettier answer. But if you want me to check your answer tomorrow, I can see if you're on the right track regardless. Alright, So, my niece Violet is here to cheer you on. She has hair that kind of has a mind of its own. This was us this weekend, wedding dress shopping. Say hello, Violet. Her hair literally sticks up like that all the time. Anyway. So, for these next few, I want you to take, again, like 30 seconds. Figure out which rule you would maybe use to solve these. There is one that works the best, and I'll let you know which one in a second. But take a few seconds, see if you can figure out which rule is probably the easiest, and then we'll talk. Okay, so for the first one, believe it or not, you can just straight up use the power rule, which is awesome. You don't have to use quotient because, remember, the derivative of 8 would just be 0, so it literally like cancels everything out anyway. Sorry, I'm apparently dying. So if you distribute the 4 through, you can actually simplify with the 8. So you end up with 5x cubed over 2. The next one, again, use the power rule because you can distribute the 6, rewrite this as x squared over 6 plus x over 2, and then, you know, just use the power rule. So y prime equals 2x over 6, but then that reduces to x over 3, plus 1/2. Sweet. The third one, I would definitely use the quotient rule. So I would distribute the -3 first and then use the quotient rule. So this is really like negative 9x plus 6x squared over 7x. And then your derivative is low. Oh gosh. D high, which is negative 9 plus 12x minus high. D low, which is 7, sorry. All over 7x squared, which is really 49x squared because you have to distribute that. You should distribute that. Once you multiply everything through and simplify, it ends up being 18x minus 18 over 7x. If you ended up with like 18 sevenths minus 18 over 7x, that also works as well. All right, the next question I would like for you to, darn it, to figure out is the right-hand side, because that was kind of a challenging, long question. If you need to see the answer written out from the previous question, just so you know, it was 18x minus 18 over 7x. This one, you actually don't need to use the quotient rule again because you can just turn this into 9/5 x to the -2. Use the power rule, so much easier, right? So use the e's. It ends up being negative 18, sorry Violet, I'm going into your picture, over 5x cubed. That's the fourth one, okay? The next question, I would actually like you to try this on your own again. I'm going to give you the answer in a few minutes, but I want you to try to see if you can figure out the tangent line because we've done this at a few times. Don't be confused that they give you a coordinate because they just plugged in the -2 for you, so it just means less work for you. Again, if you want to leave it in point slope form like we did today, feel free. I'll also give you the answer in slope intercept form so you can double check. All right, hopefully you got either y plus 4 equals 5 times x plus 2 if it's point slope form, or y equals 5x plus 16. That does not sound right. Maybe it's plus 6. That's a 6. Sorry. It's y equals 5x plus 6. That's the equation of the tangent line. If you didn't get that, please feel free to come and see me or just double check your work. I'm not going to go through the whole thing because we've done it before. All right. For the next little bit here, guys, you're going to actually have to look at the graphs. And what I want you to think about is if you're using the quotient rule or the product rule, you can actually write it out and then just plug in what you know, okay? So for this first part, let's just look at the top graphs. It asks you to find P prime of 4 and Q prime of 8. So I just want to remind you that for the product rule, if you're multiplying two functions, you would actually want to find f of x times g prime of x, we're just using the product rule here because they're giving us a product, plus g of x times f prime of x. And then if we plug in what x is, it's 4. So basically you're looking at the graph to see what f of 4 is and what g prime of 4 is, what g of 4 is, and then what f prime of 4 is. If you look at the graph, f of 4 is literally 5. G prime of 4 is going to be a slope, which, if you look at a little box that we create here, you can figure out the exact slope. So the slope on this entire length between 3 and 6 on G is going to be negative 1/2. Because remember, the derivative is just the slope. Now, if you look at G of 4, it's going to be like, I would say like 3.5 if you look at the y-axis. And then f prime of 4, if you look at the slope here, is going to be negative 1. So that's what you plug in. And then you just simplify. So if you multiply all that through, do all the maths, you get negative 6. Ooh, cool. All right. Then q prime of 8, remember low d high. So low d high, because it's division here. Oh gosh, that's a terrible f. Minus high d low all over low squared. And then now you're just plugging in 8s. So I'm actually just going to erase the x's and plug in 8s for those. 8, 8, 8, 8. Okay. So g of 8, 2. F prime of 8. If you look at the slope on the graph, again, it is about, f prime of 8 is going to be about 2-ish again. Minus f of 8 is 6. G prime of 8, what is the slope here? If I could circle it, that would be helpful. There we go. Horizontal line, 0. All over, we already found g of 8, which was 2, but 2 squared is 4. So when you simplify that all out, you get 4 over 4, which is 1. Sweet. Goodness gracious. Okay. I would like for you to try the same thing on the bottom graph, or the bottom graph, there's no graph. The bottom expressions. Use the information they gave you, write out the formulas like I did here as well, and plug in what you know. So again, I'll go through whatever questions you have, but I want you to try it. I'm going to just give you the answers with no work. So that way it'll be a shorter video for you, and you guys can help each other out if you get stuck as well, but I'll help you on Wednesday. Alright, so letter A, I'm really hopeful that y'all got 10. That's a 10, not a 16. Sorry. And the other one is 1/8. So what's cool is that you can kind of ignore the 6 for a while and then just deal with that later. But then you have to subtract that, which I did not do originally, which then gives you 47/8. If you had trouble with that one again, just ask me later. The last thing thing besides a little bit more with derivatives that we're looking at is derivatives of more trig functions. So we're not going to derive these like we did the other ones. You're just going to have to use them, but they're actually not that bad if you just plug them in. So move along to the next page with me. Alright, so there's only 4 that you have to use here. So we have tangent, cotangent, secant, and cosecant. So we had already gone over sine and cosine, but now we're just plugging in for the rest. What's nice is, again, they're not terrible. You don't really have to use, most identities are not going to be used here, so you don't have to worry about that. But if we plug in what we know that the derivative of x is just 1. So don't overcomplicate that. Then the derivative of tangent of x is just secant squared of x. Now, that is an identity, which I would want you to use. Most of them you will not have to, but I know that sine squared x plus cosine squared x is 1. Which also means that I know that if I divide both sides by cosine squared, then I'll end up with a secant squared somewhere in there. Sine squared over cosine squared is tangent squared, plus 1 equals secant squared. So if I subtract the 1 on both sides, I'm left with tangent squared of x. Weird. Oh, I lied. Negative tangent squared of x. Because you have to subtract the 1, the secant squared from the 1, and then move the tangent squared over. Okay. So, on the bottom part, treat them like they're 2 separate expressions. Okay, so literally take the derivative of cosecant and then subtract the derivative of cotangent. Okay, so when you work that out, oh, that's moving too. Turn it. The derivative of cosecant of x is just, not, stop. Okay, there we go. Y prime equals negative cosecant x cotangent x, which don't try to simplify that because it doesn't simplify. Cosecant is 1 over sine. Cotangent is cosine over sine. So if you tried to simplify that, that would be cosine over sine squared, which does not get you anywhere. Minus the derivative of cotangent, negative cosecant squared of x. Don't try to simplify this more. There's no identity that's really going to work here. All you have to do is distribute the negative. And that is it. That's all she wrote. Literally, that's all I wrote. Alright. Try these next 2. See if you can work them out. For the denominator, I mean the one that has a denominator, use the quotient rule. Okay, so this one actually can simplify a little bit. Once you combine everything together, just use your reciprocal identities from last year. Again, I can go through more questions tomorrow if you get stuck, but for the first one, use the product rule first. So first times the derivative of second plus second times the derivative of the first. Pause the video, try both, and I will show the answers in a sec. Alrighty, so derivative of the first is going to be x secant x tan x plus secant x. That's it. You can't combine them together because the first part has different variables going on. The bottom one ends up simplifying to 2 tan squared of x sine of x. So if you ended up with 2 secant x tangent x over cosecant squared of x, you can simplify that a little bit because secant is 1 over cosine. Tangent is sine over cosine. But then cosecant squared, if you have 1 over that, is like sine squared. So one of them cancels, which is kind of convenient. If you didn't simplify, you probably ended up with something like 2 secant x tangent x over cosecant squared of x. just know you can simplify it a little bit. So, higher order derivatives. Bottom part of this. If you look at the bottom, we know that the position function is either going to be your s of t equals negative 16t squared plus v sub 0t plus s sub 0, or if you're talking about meters, s of t equals negative 4.9t squared plus v sub 0t plus s sub 0. The velocity functions we know for the each piece of that are going to be v of t equals negative 32t plus v sub 0, and then v of t equals negative 9.8 t plus v sub 0 for meters. What we didn't know before is that the derivative of velocity is actually going to be acceleration. So you can figure out if you're speeding up or slowing down at a certain point by finding the derivative there. So we're going to do a lot more application with that probably next week, but a of t for feet is literally just going to be negative 32, and for velocity is just negative 9.8. So what's weird is that they're just values. And what happens with balls that are thrown in the air is that if they're thrown in the air, they're actually going to decelerate as they are moving up in the air. So that's why it's going to be those negative values. Now, don't get overwhelmed by this. It actually is not as bad as you think. Literally, the second derivative of something is just the derivative of the derivative. And it'll make a lot more sense when we go through examples. But you can continue to go until an infinite amount of derivatives. But what happens a lot of times is you end up with 0 eventually, especially with polynomials. So if we found the second derivative of this polynomial, you literally find the first derivative. So f prime of x equals 5x to the fourth plus 8x to the third minus 12x squared plus 6x minus 7. Now, the second derivative is just the derivative of that. So 20x cubed plus 24x squared minus 24x plus 6. That's literally second derivatives. So try to do that for the bottom one. You're going to find the third derivative. So take the derivative, take it again, and take it one more time. So the first derivative was 1 minus 64x to the negative 3, and I just left it like that because I knew I was going to have to continue. So the second derivative was just going to be 192x to the negative fourth, which means the third derivative is literally just going to be negative 768 over x to the fifth. And last but not least, I would like for you to try the two that are there. Pause the video. I will give you some answers in a second. For the bottom one, again, if they're giving you the second derivative, just find the third, which means find the derivative, and then find it again to find the fourth. Okay? Okay, so for the first one, you should have had cosecant cubed x plus cosecant x cotangent x cotangent squared x, because the first derivative was negative cosecant cotangent, and then you had to use the product rule. And then I actually simplified from there, so I just multiplied out a little bit, combined like terms slightly. For the bottom one, the third derivative, again, if you rewrite this as 5x to the 1/3, the third derivative would have been 5/3 x to the negative 2/3. Leave it as a negative because you're just going to have to find the derivative again anyway. And then you end up with, for the fourth derivative, negative 10 over 9 to the cube root of x to the 5th. Woo! You are done. Enjoy. If you finished early, just work on your textbook homework for me. But if you have questions, please come see me, or you can ask me tomorrow in class. Have an awesome rest of your day, and I hope it's a good one.